Math, Grade 6, Vertical Angles. Before we learn about vertical angles, let us remember together the definition of adjacent angles. Given two intersecting lines, xy and zt. These two intersecting lines intersect at O. How many angles do we have in this figure? Yes, we have 4 angles. YOT, YOZ, ZOX, and XOT. Do we have adjacent angles? Of course we do. YOZ and YOT are adjacent angles. Let us remember together the definition of adjacent angles. Two angles are adjacent if they have a common vertex, they have a common side, and they don't overlap. So they have a common vertex O, a common side OY, and they don't overlap. It means they are located on either side of the common side OY, one to the left and one to the right of OY. Same explanation, we have other adjacent angles, YOT and TOX. The common side is OT. They don't overlap. We have TOX and XOZ, also adjacent angles with common vertex O and common side OX, and they don't overlap. And we have XOZ and ZOY, two adjacent angles with common vertex O and common side OZ, and they don't overlap. So whenever we have two intersecting lines, we have 4 pairs of adjacent angles. Now let's learn the definition of vertical angles. Given two intersecting lines, xy and zt, these two lines intersect at O. We've said before that there are 4 angles in this figure, and we have 4 pairs of adjacent angles. Now let us change the order of the angles and take 2 different angles, for example YOT and ZOX. These 2 angles are facing each other. They are opposite to each other. Can these angles be adjacent? No, they can't, because they don't have a common side. We call these 2 angles vertical angles. 2 angles are vertical if they have a common vertex. Here the common vertex is O. And the half lines that form their sides are opposite to each other. So the sides of the first angle are opposite to the sides of the second angle. If you extend the sides of the first, you get the sides of the second. For example, if you extend OZ, you get OT. If you extend OX, you get OY. You see how the sides are opposite to each other? Let's focus now on a different pair of angles. Let's take YOZ and TOX. Are these 2 angles adjacent? No, they're not, because they don't have a common side. These two angles are opposite to each other. Are they vertical? Let's remember the definition. Two angles are vertical if they have a common vertex. Do these angles have a common vertex? Yes, the common vertex is O. Now, the half lines that form their sides are opposite to each other. Are the sides of the first opposite to the sides of the second? Let's see. If we extend OZ, we get OT. And if we extend OY, we get OX. So the sides are opposite to each other. Therefore, the angles are vertical angles. Two intersecting lines form two pairs of vertical angles. XOV and UOY are vertical angles. They are obtuse. XOU and VOY are vertical angles. They are acute. So we have two pairs of vertical angles. One pair of acute angles and another pair of obtuse angles. So when I say vertical angles, I say 2 points. First, they should have a common vertex. Given these two angles, AOB and COD, what's the vertex in the angle AOB? It is O. And what's the vertex of the angle COD? It is also O. So these two angles have a common vertex, O. Now the second point, let's focus on the sides of these angles. Their sides are opposite to each other. If we have these angles again, what are the sides of the angle AOB? OA and OB. Yes, and what are the sides of the angle COD? OC and OD. You can see that the sides are opposite to each other. If you extend the sides of AOB, you get the sides of COD. Example 1. In this figure, the two angles XOZ and TOY have a common vertex O. And what are the sides of these angles? What are the sides of XOZ? OX and OZ. And what are the sides of TOY? OT and OY. Are their sides opposite to each other? Let's see, if we extend OX, we get OY. And if we extend OZ, we get OT. So yes, the half lines that form their sides are opposite to each other. Therefore, the two angles are vertical. Example 2. Given the two angles FDE and ABC. This is the angle FDE. What's the vertex of this angle? Yes, it is D. And what's the vertex of the angle ABC? It is B. Do they have a common vertex? No, they don't. So we say that the two angles are not vertical. Example 3. Given these two angles, BOD and AOE. This is the angle BOD. What's the vertex of this angle? It is O. And this is the angle AOE. What's the vertex of this angle? It is also O. So the two angles have a common vertex O. Now for the second point, are they sides opposite to each other? First, what are the sides of BOD? They are OB and OD. What are the sides of AOE? They are OA and OE. Let us start. If we extend OB, we get OA. But if we extend OD, do we get OE? No, we don't. So OE is not opposite to OD. Therefore, the half lines that form their sides are not opposite to each other, and the angles are not vertical. Example 4. Given these two angles, XOZ and XOY. The angle XOZ has a vertex O, and the angle XOY has the same vertex O. So they both have a common vertex O. Now are their sides opposite to each other? The sides of XOZ are OX and OZ. The sides of XOY are XO and OY. So the half lines that make their sides are not opposite to each other. OZ is opposite to OY, but OX is a common side. So the sides are not opposite to each other. Therefore, the two angles are not vertical. In fact, you can notice that the two angles are adjacent since they have a common vertex O, a common side OX, and they don't overlap. They are located on either side of the common side. So from now on, whenever you see adjacent angles, you know directly that they cannot be vertical angles. Properties of vertical angles. Example 1. Given these two vertical angles, WIV and XIY, we know they are vertical because they have a common vertex I, and the half lines that make their sides are opposite to each other. Now it's time to talk about the measure of these angles. Use your protractor to measure the angle WIV. Place the center of the protractor on I. Rotate your protractor and place one of the zeros on IV. Here we will work on the inner scale. Start counting 0, 10, 20, 30, 40, 50. Is this measure reasonable? Yes, because the angle is acute. If you get 130 by mistake, you will know it's wrong because the angle is acute, not obtuse. The measure is 50 degrees. Now use your protractor again to measure the angle XIY. Place the center of the protractor on I. Place this zero on IY. We will work on the outside scale now. Start counting 0, 10, 20, 30, 40, 50. Stop at 50. Is this measure reasonable? Yes, it is, because it's an acute angle. So the measure is also 50 degrees. What do you notice? Yes, they are equal. VIW equal XIY equal 50 degrees. Is this a coincidence? We don't know. Let us try another example with another pair of vertical angles in this figure. Example 2. Given this figure again, do we have another pair of vertical angles? Yes, we do. The obtuse angles WIX and YIV. Now, are they equal? Use your protractor to measure these two angles. First, put the protractor on I. Place one of the zeros on one of the sides. Here I place the zero on the inner scale on IW. Start counting till IX. The measure is 130 degrees. Is it a reasonable measure? Yes, because the angle is obtuse. So we write the measure 130 degrees on the figure. For the next angle, measure the angle. Here I chose to put the zero on the inner scale on the side IY. Start counting till you reach IV. The measure is 130 degrees again. So what do you notice? XIW equal YIV equal 130 degrees. So there's the property that says the two vertical angles are congruent. It means they have equal measure. So let's repeat. Vertical angles, we have the definition and the property. For the definition, we have 2 points. First, they should have a common vertex. Second, the half lines that make their sides are opposite to each other. Remember that adjacent angles can never be vertical angles, and vice versa. Vertical angles can never be adjacent. Now, once you show that two angles are vertical, you can use this property and say that they are congruent. They have equal measure. Without using your protractor, simply you say they are equal, they are congruent because they are vertical angles. Thank you.